checking 1, 2, 3. Right, so we continue from last time. What we stopped from last time was section 3.2. We stopped at the first part, the arc length. So the length of the arc S is given by the radius times theta. Theta has to be in radian, so that's very important that theta has to be in radian. S is the length and R is the radius. So that's the first part of the section. Now to the second part is the area of a sector. I'll just continue. Two. A sector, let me just draw that out. Where's the things? Say that we have a piece of a part of a circle, 2 radius. If we have the arc length and angle here, theta. Right. A sector is the whole part like that. So a sector of a circle is a region bounded by 2 radius or 2 radii. So we have a central angle formed by 2 radii and then the arc. So that is a sector bounded by 2 radii and an arc. Right. Now we try to find the formula for the sector. the area of a sector could be A, the area 1/2 r square theta. Of course, r is the radius and theta is the central angle. Have to be in radian. And the central angle has to be in radian. That is very important. Theta has to be in radian. Right. So let's try to kind of prove that in a sense. Now, we have from the previous part of the section, the arc length. This length here is given by r times theta. Right? The arc length, the length of this arc, given by that. Now, instead of draw arc like that, I will draw it like that. This is the arc length S, and we have 2 radii here. Now, of course, if that is a radii, anything like this is also a radii, right? It's also a radius, so we have a bunch of radii. Now, think about this as a triangle, because that's very close to a triangle, right? The area of that, if we think this, if we take this as the base of the triangle, kind of the base, and that is kind of the height, and the area is 1/2 base times height. So that looks like a triangle, and the formula for a triangle is 1/2 base times height. And now we just substitute that part into S. We have 1/2. Instead of S, we have r times theta for S, and then times r again, and r times r, 1/2 r square, r times r square times theta. So that's where this formula comes from. It's 1/2 r square theta, because of it looks like a triangle, and the formula will be similar to it. Right. So let's look at the first example. How many square inches of a pizza has a person eaten? Of course, the easiest example that we can come up with is the piece of the pizza is a sector. So, how many square inches? A pizza has a person if in a sector of 18-inch diameter pieces. Whose edge from edges from a 30-degree angle. Right, so this is not that bad. We just need to write out everything we know and what we're looking for. So how many square inches? So that obviously they ask for the area. Right, so what do we have? 18 inches in diameter. The problem is this is not the radius. In the formula we need to have the radius. So diameter is equal to 18 inches, meaning that the radius is going to be half of the diameter. So it will be 9 inches. Right, and the edge from a 30 degrees angle. So we know the angle is 30 degrees, which is good. However, the unit theta has to be in radian. So we'll change to radian. And to change to radian, what we do is we multiply by something that will cancel the degrees. So we put 180 degrees at the bottom and pi on the top. In that case, the degrees cancel out. We have 30 pi divided by 180. And 30 divided by 180 cancel out. We have pi over 6. The unit on angle, it can be radian. So we can write radian or not, it doesn't matter. Radian is a nice unit so that we can put it in or take it out or don't write it at all. It's still fine. But so that is radian. And finally, the area is equal to 1/2 radius square times theta. Now, 1/2. The radius is 9 inches. We may or may not put the unit. It doesn't really matter. But let's put unit in this time. And then the theta will be pi over 6 radian. It doesn't matter if we have the radian or not. It doesn't really matter. Right, so 1/2. 9 square is 81. In square is square inches. Pi over 6. Like I said, the radian can just cancel by itself. Yeah. And I will just do the math. So that's simple enough. 81 divided by 2 times 6. So multiply everything on the top. We have 81 pi on the top. And the bottom, 2 times 6. So 81 divided by 12. Usually I will leave the pi out of the problem. And then stick the 4 at the end. Of course, I forgot the inches. So there. And if we want an approximation, take 27 divided by 4 times pi approximately about 21.2 inches square. Right, so just like that, very straightforward. Oops. Right, we have the next problem. So pretty straightforward. Just make sure that we have to have the radius, not the diameter, and angle have to be in radian. Right, so that's all. Right. Right, the next example, a goat is tether the corner of a fence. So we assume that the fence is 90 degrees. Okay, let me just write out the problem. At the 90-degree angle. Right. So we have the corner, the fence, like that, and the goat tethered by the 10-foot rope. So the rope is 10 feet. And assume that the goat can go anywhere within this region. And the question is, find the area of land. So obviously we're talking about this land. And so once again, we're asked to find the area. And what we know is the rope is 10 feet, meaning that the goat can go to full extent, it can go back and eat anywhere within this corner of the fence. So theta is 90 degrees, because that's what given. But once again, it has to be in radian. So we don't want degree, so put degree at the bottom and pi on the top. We did this from the last section. degree cancel out. 90 pi divided by 180. 90 and 180, so that pi over 2. Once again, radian, we can put it in or take it out if we want to. Right. So that is the angle. Next, the radius is the length of the rope, 10 feet. Right. And the question asks for the area. So that's easy enough. 1/2 radius 10 feet square pi over 2 radian. Radian can cancel by itself. Cancel itself. Uh, 10 feet square is 100 square feet pi over 2. Right, so on the top we have 100 feet and pi, so 100 pi and square feet. The bottom 2 and 2. 100 divided by 4, 25, so we have 25 pi square feet. And 25 pi is approximately equal to 78.5 square feet. So pretty straightforward. Right. With that, we go to section 3.3. There will be more problem on the homework. Right, unit circle. A circle whose radius is 1 unit and center is at the origin. Is called the unit circle. And the equation squared plus y squared equal to 1. Before we continue, I want to go back to all the quick reference part that we have. So again, we have special values angle. Get back to that in a minute. Definition of trig function. We can define things on x, y, and r, or we can define using opposite, hypotenuse, and adjacent. So that these are two different definitions of trigonometric functions. We have two definitions. One using x, y, and r, one using opposite, hypotenuse, and adjacent. This definition works only for an acute angle. So now we get back to this one, x, y, and r. Now, in this case, since it is called a unit circle, the radius is 1 unit. So r is equal to 1. Now we have this ratio. If we let r equal to 1, then we have a new definition for a trigonometric function. Since r equal to 1, we define six trigonometric function. For a point xy on the unit circle whose arc length s from 1, 0 to x and y. Right. After all of that, let me just write the definition first. Now, this is what the definition we have earlier. That is the definition we have earlier. Right? Now we let r equal to 1. Instead of s, instead of theta, we're going to use s. So sine s equal to y. Yeah. And cosecant of s equal to 1 over y, because r equal to 1. Cosine equal to x, because r is equal to 1, and secant of s equal to 1 over x. Tangent will be the same, y over x, and cotangent should be s. Should be s x over y, and because when we divide by anything, it cannot be equal to 0. Right. Now, the difference between all of this definition, once again, we should have a circle. So let me draw at least part of a circle. pencil is a bad choice. Difficult to see on the camera. Now, the radius is 1. So suddenly it will go to the point 1 and 0. And here the point 0 and 1. Because the radius is r equal to 1. Now, remember, we talked about the arc length earlier. If we have the point, let's say x and y, we have the arc length and this function is defined is a function of the arc length s. And since r equal to 1, the arc length equal to r times theta. And since r equal to 1, we have s is equal to theta. By the way, the unit for s and the unit for theta are different. So writing like this without the unit kind of a bad thing. However, in terms of the values, if we talk about the numbers only, the arc length is equal to theta. So in which case, we have the definition. Instead of defined by theta, we define by the arc length s. So this function, we call the circular function, is defined on the arc length s. And because when we define like this, whatever the denominator is, denominator cannot be equal to 0. Right. Now, next, I'm going to draw two circles. The definition is too big to fit on the note, but so I'll try to draw a circle. Only the upper half will be enough. Let the radius be about this much. Once again, just hold this very steady. The center is very steady, and just move the paper. Never move the pen. Never move the hand. That gives us the upper half of a circle. Only move the paper. Don't move the hand. Don't move the pen. Try to do that again. Now, again, this is the unit circle, so the radius is always 1. So that is the radius is equal to 1. Now, what I'm trying to draw the definition here is, let's say we have a point here. if the point is there, this is going to be y values, and the horizontal distance is the x values. By the definition, y is equal to sine, so we have sine is that one of s, and the horizontal is x values, which is cosine. Right, so that's easy. Where would be the tangent and the secant, cosecant, cotangent? Right, now if I draw the extending this line, again pencil is the best choice. We draw a line through the center. By the way, this is theta, and this is s. The arc length, the center angle. Now, what we do is we're going to draw the tangent line at this point. And the tangent line will cut at that point. Right. Once again, when we have a point, we have sine and cosine. Now, the point here is going to be tangent. I mean, that distance here is tangent. Then you say, why is that? Now, think about this. We have two right triangles. This is the first right triangle. And this is the bigger right triangle. So, two right triangles. Now, with respect to that angle theta here, we have opposite over adjacent, opposite over adjacent. So when we write tangent of theta or tangent of s, opposite over adjacent, this also cosine. So opposite over adjacent, and opposite over adjacent, which is 1. Yeah. So that's why the distance here from on the tangent line is tangent, and that's why it has the name tangent, because it is a tangent line. Now, when we have the tangent, this is going to be secant. So secant. By the way, if you look it up in the Greek language, tangent means touch and secant means cut. So tangent means touch and secant. I forgot the Greek word, but it comes from the word that means cut. So the line that cut the circle give us the secant, and the line that touch the circle give us the tangent. Right. Now similarly, we define cotangent and cosecant, but this time we draw the tangent line here. And the secant line, and the line is still cut like this. Once again, x, y, y, and x. Y is sine, cosine is s, theta, arc length this time that distance here is cotangent. And the whole line that cut to the center is cosecant. So that is the visual line of the function on the unit circle. Right. The way we define the function based on s is called the circular function, because we define that based on a circle. So once again, the y values is sine, the x values is cosine, simply because if we let r equal to 1, we just have y divided by 1, or just y. Right. Tangent meaning touching at the x-axis give us tangent, touching the y-axis give us cotangent. And secant mean cut into the center is secant and cosecant respectively. Right, that's what we have. Now we go to some example. So let s equal to pi. Find sine s and cosine of s. Right. Circular function. So we're going to draw a circle. Pi, by the way, where's pi? By the way, pi radian is equal to 180 degrees. We always have that. So this corresponding to 180 degrees. And this is the unit circle. So the point here is equal to x equal to -1, y equal to 0. So we find sine of pi. Now sine is equal to y, and cosine is equal to x. The y values is equal to 0. The x values is equal to -1. So what we will do next is we're going to find a bunch of different values of the trig function. well, I lied, we only do 2 of them, but then we go to the unit circle. It's going to be very difficult to do that, right? But remember, we always have this definition, right? That from Secant chapter 1, and we have the hand. Remember, 0 degrees, 30, 45, 60, and 90 degrees. Correspondingly, we have 0, pi over 6, pi over 4, pi over 3, and pi over 2. So keep that in mind. We have this. 0 degrees is 0 radian. 30 degrees, pi over 6 radian. 45 degrees, pi over 4 radians. 60 degrees, pi over 3 radians. And 90 degrees, pi over 2 radians. So we have that. And then the definition using the hand. So that's what we have. And also the definition using x, y, and r. Right. Now we have some example here too. Find sine of negative pi over 6. Right. Now we do the long way first. Let's convert the negative pi over 6 to degrees. See what happens. Negative pi over 6. If we want degrees, multiply 180 degrees on top because we want degree, and then put pi radian at the bottom. So that's how we go from degrees, from radian to degrees. Pi and pi cancel out. Negative 180 divided by 6 is negative 30 degrees. Right. Now, next. How do we find the values for negative sine of 30 degrees? Right, first, obviously 30 degrees, the reference angle is 30 degrees because 30 only divided by 30. So first, the reference, I don't know what color we used earlier, but we find the reference angle. Which is 30 degrees. Now ignore the sine, it doesn't matter. We find the sine of the reference angle. Right? That's the right hand or left hand, it doesn't matter. Right, 30 degrees. Right there. There's one finger on the right. We take square root of that. Divide by 2. So it's 1/2. So the values is that. Next we determine the sine. Is that positive or negative? Right. Negative 30 degrees is in here, right? And if the point is in here, x is positive, y is negative, but r is always positive. And sine is y over r. Negative divided by positive is negative. So the answer is negative 1/2. Right, so that's what we did earlier. We used the reference angle to find the values, and we use the quadrant to determine the sine. Right, that's what we did earlier. By the way, if we use the calculator, make sure it is in the right mode. Sine of negative 30 degrees. Yeah, negative 1/2. And also, I need to mention this as well. Negative 30 degrees is here. If we have the radius, the hypotenuse is 1, the y values and the x values, sine corresponding to the s values, I mean with the y values. Because it's going down, it's going to be negative. And this is the 30, 90, and 60 degrees triangle. Corresponding to 30, 60, and 90 is 1/2 squared 3/2 and 1. So we have 30 degrees, 60 degrees, and 90 degrees. Corresponding to that is the length 1/2 squared 3/2 and 1. Those are the ratio. So that's why this is 1/2 going down, so it's negative. So there are a lot of different ways to determine the trig, the values of a trig function like that. Right. Next, skip that example. We go to the unit circle. See if I have a compass. I don't know where I put the compass away, but that's alright. Always rub ahead. So I'm going to draw a very big circle. And I do this way, as always. Once again, just hold like this, very steady. Put a few fingers in between. It doesn't matter. Okay, like that. Hold that steady. The pen and the hand have to be very steady. Just rotate the paper. Right. Close enough. So we have a circle. Just rotate the paper. So we just have a circle like this, the x-axis and the y-axis. Right. Next, we will divide this in half. I run this paper with the grid, so it's very easy to divide this in half. I mean, each quadrant in half. I use different color here. right? So divide each quadrant in half. Now, each of this, divide that into 3 quadrants. The best way to divide in 3 quadrants is this. Just trying to find the distance. It will be easier if we have a compass. Right. So that distance. And the same distance here. So we divide the whole thing into 3 equal pieces. Again, we have the length the same as the radii. Too long. I said it would be easier with the compass. Just about here. Right. So what we have here, once again, a circle. It goes from 0 degrees here and to 180 degrees there. In terms of pi, it will go from 0 and the pi there. Right. By the way, I'll take 5-minute break here. I'll let you catch up and draw that circle. Where we continue. Within 5 minutes, so 2:05. We continue. Once again, a circle. Half of that is 180 degrees. The others 0 and pi, so equivalently. So I will write the degrees first. 90 degrees, 270 degrees, equivalently pi over 2, and then 3 pi over 2. So 0, half a pi, pi, 3 halves of a pi. Right, now divide this into 4 pieces. Now I'm talking about these 4 points. Half of 0 to 90 degrees is 45, right? So we have 45 degrees. Half of that is pi over 4. Now, think about this. 0, 45, 2 times 45, 3 times 45 is 135 degrees. 4 times 45 is 180. 5 times 45 is 225. 6 times 45 is 270. 7 times 45 is 315. Right? 1 times 45, 2 times 45, 3 times 45, 4, 5, 6, and 7 times 45. Now, the same thing. 0, pi over 4, 2 times pi over 4, 3 times pi over 4, 4 times pi over 4 times pi over 4. So this, if I want to write, I can say 4 pi over 4, which reduce to, of course, pi. Four pi over 4. This is 5 pi over 4. I can write this as 6 pi over 4, but that reduced to 3 pi over 2. And then 6 pi over 4, 7 pi over 4. So we have those values. I guess I have to switch the colors here. So now this (0 to 90 degrees), divide that into 3 equal segments. So we go 0 to 30. So that is 30, 60, 90, 120, 150, 180, 210, 240, 270, 300. And 330. Now in terms of radian, pi over 2 divided by 3 will be pi over 6. Two pi over 6. 2 of pi over 6 cancel out, just pi over 3. and then pi over 2 this. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6 is 3 pi over 2. 2 pi over 3. So 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6 is 4 pi over 3. 9 pi over 6, 10 pi over 6, so 5 pi over 3, 10 pi over 6, 11 pi over 6. Right, so we have the values. Kind of scram, but because I try to fit everything on full in the screen, and that's the only thing we can do is like that. Right, now the values. This point we have y values and x values. So the coordinate is x equal to square root of 3 over 2 and 1/2. And we have the rest of the point. Right, so don't worry, I'm going to send you the unit circle completely filled out all of the data with everything nicely. But what I want you to pay attention on is this. When we have a point, trying to draw the line that is vertical line and horizontal line will form a square or rectangle. Notice the characteristic of this is all of them are divided by 4. Right? Now, same thing. If we try to draw a line that is perfectly down, vertical or horizontal, if we form a rectangle like this, pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Right? So on the edge of the rectangles or the square, the denominator will be the same. So that is the important here. That is very important. What we're trying to say is the reference angle of anything, let's say if a radian measure is a reduced fraction. So if we write the radian in the reduced fraction, whose denominator is, if the denominator is 6, then reference angle is pi over 6. If the denominator is is 4, then reference angle is 4. Is pi over 4. And I hate when we do this, but if the reference if the denominator is 3, then the reference angle is pi over 3. And if it is 2, then the reference angle is pi over 2. And actually, yes, the reference angle right, keep that in mind. So in a sense, after we get used to this, it will be very easy to find the trig function in radian measure. We'll see. Let's go to example. Like I said, I will send a picture of the unit circle to you, and if you have the printer, I recommend you bring this out for a quick reference. First, sine of 5 pi over 4. What is that? Right. So, what we did earlier is when we trying to find that, we do two things. First, use the reference angle to find the values. Second, use the quadrant to find the sine. So, let me write that important steps. So the first step is the reference angle give the values. 2, the quadrant give the sine. Right, those two steps. Now, first step is the reference angle. Five over 4. It's not a pi though. Divide by 4, so it is reduced fraction, right? What is not reduced is something like 6 pi over 8. This is not reduced. But the 5 pi over 4, it is reduced. So if it is reduced and the bottom is 4, the reference angle is pi over 4. So it's simple as that. Now what is sine of pi over 4? Back to this. Pi over 4. So 0, pi over 6, pi over 4, pi over 3, and pi over 2. So pi over 4. Sine is the number of the fingers on the right, and there are 2 fingers on the right. Square root of 2 over 2. So that is the values. Next, the quadrant. Five divided by 4. What is that? 5 divided by 4 is 1 and 2 5. Right. So now if we write in terms of a circle, we have 0, 1 pi, which is 180, half a pi, 90 degrees, and 1.5 of a pi, is here. So we have 1.25. So it will be in here. Right? 1.25 is between 1 and 1.5. So this is in quadrant 3. Quadrant 3, x is negative, y is negative, and r is always positive. And we have sine is y over r. So this is negative. So the answer is negative square root of 2 over 2. Yeah. So that's what we do. By the way, when we get used to this, we can do in our head. And that's most of the time. Unless you try to memorize everything like the multiplication table. I actually don't multiply. I actually don't memorize it. I just try to do this very, very quick. Right, cosine of negative pi over 3. First, reference angle. This is a reduced fraction, 3 at the bottom, so we have pi over 3. Now, cosine of pi over 3 and cosine is the number of fingers on the left. Square root of that divided by 2, so it's 1/2. Now the quadrant. Zero, 0.5 pi, 1 pi, 1.5 pi. If it go clockwise, this one negative pi over 3. So what is negative 1 divided by 3? So it's about that, which is go clockwise. So it is about here. In quadrant 4. In quadrant I got a question. The reference angle has to be between 0 and 90 degrees. So we have to pick an angle that is between 0 to 90 degrees or 0 to pi. So that's why, remember, this only works for anything from 0 to 90 degrees. So we have to go from any angle into a reference angle. And the way we do that is, if that is the reduced fraction divided by 4, this is pi over 4. Reduced fraction divided by 3, it's going to be pi over 3. We're just going to ignore the rest of the problem and find the values. It has to be in this in order to use the hand rule. That's why we go that to pi over 4. Yeah. Of course, if you have the whole unit circle, you just go ahead and find the values. Right. I should have the unit circle somewhere. Let me give me a minute. No, it's not multiplied by 5. It is divided by 4. So if it is a reduced fraction, we just take the 1 at the bottom. Pi over that is going to be the reference angle. If it is 2, 3, 4, and 6. So once again, when we look at the fraction, if it is reduced, the bottom is 4, then pi over 4 is the reference angle. If this is reduced fraction, 3 at the bottom, then pi over 3 is the reference angle. The same thing for 2 or 6. Right, now I'm going to give you the quick snapshot of the reference angle. Just a second. I'm going to send you this later. Right, so that is the unit circle, the complete unit circle. So later on, yes, yeah, in that case, yes, in that case, that were to give us the quadrant 4, quadrant 3. Yes, you're right about that. Yeah. So now, if you have the unit circle like that, then we go to pi over 4, right? Y values is sine, x values is cosine. So in that case, sine, we just find the y values. So that's negative square root 2 over 2. So if we have the unit circle, then we can find the values easily. Right. Cosine of negative pi over 3 will be right here. And the sine, the x is the cosine values. So all the coordinates, the first one is the x, which is cosine. The second one is y, which is sine. Yeah. So like I said, I will send you this unit circle later. Right now, I think, can we? Yeah. That works. Right now, just put it right there. Right. Back to this. This in quadrant 3, quadrant 4. X is positive, y is negative, and r is always positive. And this is cosine x over r, positive over positive is positive. So the answer is going to be positive and then 1/2. So on the unit circle, 5 pi over 3 or negative pi over 3, the x values is cosine, so it's 1/2. Sorry, you cannot see. Okay. Once again, 5 pi over 3, the x values is cosine. Next. Cotangent of 7 pi over 4. Right. To make a unit circle bigger. Should be able to see that. Right, reference angle. By the way, I'm going to do that without the unit circle. Reference angle 7 pi over 4, so that divided by pi over 4. So what is cotangent of pi over 4? Right. Cotangent is cosine divided by sine. This is pi over 4. Right. So we have 2 fingers on the left and 2 fingers on the right. They are the same, so cancel out. So this is 1. So we know the values is equal to 1. Now we determine the size. What quadrant is that? Right. 0, half a pi, 1 pi, 1.5 pi. Right. And 7 divided by 4 is 1.75. So that will be in here. In here, y is negative, x is positive. Cotangent y over x negative, sorry, x over y positive divided by negative is negative. So the answer is negative 1. Right. By the way, if we have the unit circle, yeah. Yes, on the unit circle, we just take the values. So 7 pi over 4 will be right here. Be right here. And then we just take y divided by x. So we have the x values is negative square root of 2 over 2. So we have 2 over 2. And cancel out, it is negative 1. So once again, in the unit circle, what we have is the x and the y values, which give us the cosine and the sine values. Right. Let me go back to this. For here, we have the x and the y values, which is cosine and sine. Yeah. So when we look in the unit circle, the coordinate is cosine and sine, or x and y. So it's always trying to find cosine and sine first, and then we can determine the rest. So it's either we're using the unit circle, or if we don't have the unit circle, then we have to go with this and the signs. Right. Now let's use the unit circle here and forget about the hand. Right. I can make that even bigger. So, secant of negative 2 pi over 3. Okay. So 2 pi over 3 if we go 2 pi over 3, it will be this point, right? But if we go negative, it have to be the opposite direction and will be this point. Right? So counterclockwise is positive. Clockwise is negative. So we go clockwise negative. So that will be the point that I have, the pointer, the mouse pointer will be here. Here. Right there. Now secant. Secant, what is the definition for secant? That is secant, but r is the radius is equal to 1. So which is 1 over x. Right, which corresponding to that point over there, what is the x value is equal to? Right, if this is the point, x will be equal to negative 1/2, right? And 1 divided by fraction is reciprocal, so that will be negative 2 over 1, which is negative 2. So that's it. So if we have a unit circle, that will be very easy to find all the values. Could be in degrees, could be in the radian. Right. I'll just make up some example here. Let's try to find sine of 11 pi over 6. So on the unit circle, you see over there, 11 pi over 6 is here. And sine is equal to the y values. The y values corresponding to that point is negative 1/2. So simple enough, right? Right. Just find the point. The x values is the cosine, the y values is the sine. Right. Of course, if you have that unit circle, so it could be very easy. Right. And then how about the tangent, cotangent, secant, and cosecant? Well, that's not too bad. We define cosine is x, secant is 1 over x, cosecant is 1 over y, tangent y over x, cotangent x over y. So pretty much, let me precise the unit circle. Pretty much, it is just this ratio, but r is equal to 1, and then we just find the values easily. Let's go with another one. I'm just make up an example here. How about we find tangent of 5 pi over 3? So first, tangent is y over x, right? So 5 pi over 3, look on the unit circle. Five pi over 3 will be right here. The y values is negative square root of 3 over 2. And the x values is 1/2. right? The first is the x values, the second coordinate is the y values. So multiply reciprocal, divide by 1/2, multiply by 2 over 1. 2 and 2 cancel out. So that's all we do. So if we have a unit circle, things will be extremely easy. Find the x values, find the y values, find the trig values. That's pretty much it. Number 4. Domains. Right. Alright, domain of circular function. I will go back to this part. First, domain of sine and cosine. Domain of sine and cosine, we define sine is equal to the y values and cosine is the x values. And obviously, doesn't matter where the point on the unit circle, x and y is always defined. So it is defined everywhere. So the domain is negative infinity to infinity. Next. Domain of tangent. And secant. Our first tangent is y over x, and secant is 1 over cosine. Cosine is x, so 1 over x. So both of them divide by x. So the domain x cannot be equal to 0. So on the unit circle, where x equal to 0, we're talking about this point. X equal to 0 and this point, which cannot be pi over 2 or 3 pi over 2. We include the coterminal, so we might go extra revolution. Bottom line, when we put this together, we can say x not equal to pi over 2 that is the domain. We cannot have those 2 points. Pi over 2, add a pi to it, add a pi to it, and we just keep doing that. C. Cotangent and cosecant. Cotangent is x over y, and cosecant is 1 over sine. Sine is y, so 1 over y. Bottom line is y cannot be equal to 0, otherwise it is undefined. And y not equal to 0 on the unit circle, we cannot have this point and this point. So x cannot be equal to 0. X cannot be equal to pi. But then, of course, we can add to pi to have coterminal angle. When we put them together, x cannot equal to pi, just do n pi. Okay. Cannot be a multiple of pi. So we have the domain of sine, cosine, domain of tangent and secant, domain of cotangent and cosecant. So, like I said, everything just go back to x, y, and r. In this special case, we will let r equal to 1, and we have the unit circle. And before we have the unit circle, then we find x, y, and then we can find the values easily. Right, section 3.4, linear and angular speed. Right. Now, of course, the definition is there, but I'm just trying to attempt to do this. So, let me write that first, and then we explain. The picture will be a lot better than what we're about to write. Suppose an object travels around a circle. Radius r. If the object travel through an angle theta and an arc length s in time t, then linear speed v equal to t, s over t, and angular speed theta divided by t. So distance divided by time. Right. Now think about this. Let's talk about the Ferris wheel, for example. So we have a circle. Now, if we track one point, and that point will travel around and around and around, we have the angular. Now if we just track the angle, it will travel around and around and around. Now if we track the point, and now if assume that we put that point on the ground, then that point will move in a horizontal distance. Now a better example, think about this. A motorcycle. Right. Of course, when the motorcycle move, we can track the point on the wheel rotate around the center, and so we can track the movement of the angle of a point going around the circle. But at the same time, that point on the ground will travel at the same distance. So in that case, we have the linear speed. If this is divided by time, we have the distance divided by time. As always, this distance divided by time, and the angular speed is the change in the angle divided by time. So one is the distance, the linear distance, and one is the angular distance, if you will. So another example is, if we're riding a car, we look at the RPM. The RPM is revolution per minute. That will tell us the rotation of the wheel. And I'm not sure if that is a different mechanical thing, but we have the RPM, that is the angular speed, and the speed of the car moving, that's like 50 miles per hour. That is the linear speed. The RPM is the angular speed. Now, let's put those things together. We have since arc length is equal to r times theta. Put this together, we have v equal to distance divided by time. Distance is the arc length, r times theta divided by t. So we have r times omega divided by t. I mean theta divided by t. So we have r equal to r times, v equal to r times omega. By the way, the angular speed defined to be, that is the omega, the Greek letter O, omega. I don't think we need the unit circle anymore. Right, so linear speed, distance divided by time, arc length divided by time, angular speed, angle divided by time. Right. Look at the first example here. A model plane is attached to the swivel so that it flies in a circular path at the end of the 12-foot while 11 revolutions per minute. Right. I'm trying to draw this here. And a model airplane we have a 12-foot wire. And airplane just travel around and around. At 11 revolution per minute, find the angular speed and the linear speed. I think I'd better write this out too. Right, so when we look at the problem, 15 revolution per minute. What is that? The 12 foot obviously is the radius, because that is the fixed distance that travel around. So what we have is the radius is 12 feet. What is 15 revolution per minute? By the way, revolution is the unit of an angle, so 15 revolution around the minute is the unit of time. So what we have is the omega 15 revolution per minute. We should write like that instead. Right, now, so find the angular speed. Actually, we have the angular speed. We just need to find the linear speed. By the way, this will need to rewrite unit conversion. 1 revolution is equal to 2 pi radian. So that the revolution and revolution cancel out. So we have 15 times 2 pi, so we have 30 pi per minute. And then we say, of course, the radian there. I said the radian is, we can just put it in or take it out at our choice. So we say 30 pi radian per minute. That is the angular speed. The linear speed, V is equal to R times omega. The radius, 12 feet. Angular speed, 30 pi radian per minute. Radian is a nice unit. We can just take it out whenever we want. So we have 12 times 30 pi. 12 times 30 is 360 pi radian. I'm sorry, we cancel the radian. feet. pi feet per minute. We can change to second too, that's fine, but 360 pi so about that much. We run out of time, but I just want to do this next one real quick so that we can have the test. I can post the test right after this. A water wheel diameter 16 feet. Assume the wheel makes 12 revolutions per minute. 12 revolutions per minute. Of course, when we write like that, we know that the angular speed revolution per 1 minute. At the angular speed. For the speed of the river. So what we have is the water wheel the river kind of right at the edge. As the river flows, the wheel turns. The wheel turns 12 revolutions per minute. The question is, find the speed of the river that causes the wheel to turn. So, speed of the river so that's what we have for the problem. So first, diameter is 16 feet. The radius, always need the radius instead of diameter, is half of that. So 16 divided by 2, 8 feet. Now, the angular speed is that 12 revolutions per minute. We don't want revolution, we want radian. 1 revolution is 2 pi radian. We can do a lot like this. If we don't want minute, let's use second instead. Then we can attach another one to it. 1 minute is 60 seconds. The standard unit, just S is the second. So minute and minute cancel out. And collect everything. We have 12 times 2 pi radian on the top. The bottom 60 seconds. So 24 pi divided by 60. 24 divided by 60. That is 2/5. 24 divided by 60, and then we have pi. Stick to it. The unit would be radian per second. Right. I'm sorry, I didn't read the question that you asked, but anyway, so that is the angular speed. In the question, when you see later on the homework on the test, it will tell you what kind of unit do we want. If we want radian per second, then we convert to radian per second like that. 1 revolution to pi radian. Put the revolution at the bottom to cancel with that. 1 minute is equal to 60 seconds. Put the minute on top to cancel, and we reduce to that. And finally, the speed of the river. That is the linear speed equal to r times omega. R radius a feet 2 pi over 5 radian per second. Radian cancel by itself. A times 2 pi will have 16 pi over 5 feet per second. So approximately 16 pi divided by 5 is about 10.03.05 feet per second. So that's the speed of the river. So bottom line is, I'm not sure if the question on the test or on the homework is over the minute or about over a second or whatever the unit of time is. But it's always the angle using radian. And linear speed equal to r times the omega. Or we can just use those formulas for the angular speed or the linear speed, either those two or this one. Anyway, so I'm going to stop the video here. Do you have any question on the test, which I'm going to post in a few hours? Right. Let me just write down the important things about the test. Oh. Right, test. There will be 3 tests in total. First, there will be 2 attempts for each test. Second, time limit. At first I thought about 90 minutes, but just in case my MATLAB has any slowness to it, I'll just make it 2 hours. And then the number of questions, usually about anywhere from 20 to 30. The first one, I think, 25 questions. 25 questions on the first test. Do you have any question about the test? I also send you a sample test so to see what the test will look like. The test is unlike the homework. When you type in the answer, each time it will not tell you if it's right or wrong. Oh, most important, of course. Yeah, you have until now, until the end of the semester to do all of the tests. So it is at your own time. I don't recommend you do all of the tests at the last day of the semester. Just pace yourself. Don't scram all of the tests at once. Right. The sample test, when I send it out, just get the feeling of what the test will be like. Right. Another question. And if you don't know what is the percent of the test, just go to the syllabus. Or if you want to see the syllabus, I think there's a video on my channel that says the structure of an online class. And then the first video that I sent out, you will see how that works. Right. If you don't have any question, I'm going to end the stream here. Yes, the chapter 1 to chapter 3. Yeah, that's just like the review. Right. So if you take the test soon, good luck. If you don't take the test right now, it's perfectly fine. Like I said, you have until the end of the semester to do those tests, to attempt each. Right. Good luck and have a good weekend. See you Tuesday. Yeah. We will not dedicate any class time for test. So the test is done on your own time.